So, when you think about AI, you probably picture it writing poems, creating art, or maybe beating a grandmaster at chess, right? But the truth is, some of the most important AI in the world is doing work that's, well, a lot more mundane. And honestly, that's what makes it so revolutionary. Today, we're going to pull back the curtain on AI's hidden real world jobs.
Okay, so if it's not just out there making headlines, what is AI actually doing? Well, for starters, it's working on a factory floor, solving a problem that is almost impossible for a human to even see. Let's dive into this.
On the left, you've got the AI we all know from science fiction, this glowing, all knowing brain. But on the right, that's the reality. It's complex, kind of messy, data streaming directly from a semiconductor factory. And this is where the real work happens, not in some abstract cloud, but deep inside the machines that build our modern world. All right, so for our first stop, we're heading to one of the most demanding manufacturing environments on the entire planet. See, building a computer chip is an unbelievably precise process. Even a flaw that's totally microscopic can be catastrophic. So how on earth do you train an AI to find a flaw that's so incredibly rare you have almost no examples of it to begin with? And this analogy just hits it perfectly. The problem is like trying to find a needle in a haystack. But here's the kicker. You've never even seen a needle before. In data science, they call this class imbalance. You might have millions of examples of a perfect product, but only a tiny handful of a faulty one. And that's just not enough data to train a reliable detector. It's basically impossible. So, the solution they came up with is, honestly, it's something straight out of sci-fi. Instead of just teaching the AI how to find the flaws, engineers built an AI that can imagine them. What you're looking at here is the model they used, a variational autoencoder, or VAE. Its job isn't just to spot errors, its main job is to get creative. So here's how this ingenious three-step process works. First, they feed the AI data from only perfect wafers. It just studies perfection, learning what normal looks like, down to the tiniest detail. Second, it crunches all that learning down into a compact, mathematical idea of a perfect wafer. And then, this is where the magic happens, it uses that idea of perfection to generate brand new, totally synthetic data of what imperfect wafers would look like. It literally creates the examples it needs to learn from.
And this is the payoff. This is the aha moment. On the left, you see the data signature from a real flawed wafer. And on the right, that's the AI's creation. I mean, look at them. They are so similar, it's uncanny. The AI successfully imagined realistic flaws, giving itself a rich data set to train on. It solved the needle in a haystack problem by learning how to make its own needle. Okay, let's switch gears completely. We're moving from a physical factory floor to the digital world. And here, the problem isn't the rarity of bad stuff, but a constant, overwhelming flood of it. This is the story of AI as a digital gatekeeper. Just think about the sheer amount of content that gets uploaded online every single day. It's just staggering. As this diagram shows, AI is really on the front lines, trying to filter this enormous variety of harmful material, everything from hate speech and spam to severe toxicity and threats. The scale is just way beyond what human moderators could ever handle alone. And this quote gets to the heart of the huge shift in thinking. For a job like content safety, the goal isn't to build the smartest AI in the world, one that can ace some academic test. No, the goal is to build a reliable one. An AI that is stable, predictable, and most importantly, doesn't cause a bunch of new problems while it's trying to solve the old ones. It's a huge move from just valuing raw intelligence to valuing operational safety. Okay, for our last example, we're going to look at a really fascinating problem that AI basically created for itself. You know, the large language models that power so much of modern AI, these things called transformers, they are incredibly powerful, but they're also incredibly inefficient. They are just ravenous for memory. This analogy just absolutely nails the problem. A transformer's superpower is that it looks at the entire context of a document to understand meaning. But its great weakness is that for every single calculation, it has to go back and reread that entire context from scratch. It has no working memory. It's wild. And this slide shows you the physical reason why this is such a problem. It's a hardware bottleneck. The AI is constantly shuffling huge amounts of data between the super fast but very small on-chip memory, that's the SRAM, and the larger but much slower main memory, the HBM. It's like trying to drink from a fire hose through a tiny straw. The whole system gets jammed up. But now there's this new method called TPT that just flips the whole thing on its head.
The old transformer, right, rereads the whole book every time. TPT, on the other hand, reads the book once, and then it creates and refers back to these intelligent, summarized notes. It's a fundamental change from brute force recalculation to efficient, smart memory. And this is what's so wild. It's completely counterintuitive. You would think that by summarizing things, you'd lose some accuracy. But it turns out the exact opposite is true. TPT uses way less memory and is way more efficient, and yet its accuracy is often maintained or even gets a little bit better. It just proves that remembering smarter is way more important than simply remembering everything. Okay, so let's just take a step back. We've seen a factory detective that literally imagines flaws, a digital gatekeeper that prizes being stable over being smart, and a memory optimizer that works smarter, not bigger. What's the thread connecting all of these? It's that AI is quietly building the invisible infrastructure of our future. What all this shows us is that we've entered a new, much more mature era of practical AI. It's an era that's defined by efficiency, not just massive scale. It's about being reliable in the real world, not just chasing the highest score on some academic benchmark. And it's about developing targeted, clever solutions for very specific, very critical problems. So you see, these hidden AIs aren't just solving today's problems. They are becoming the invisible foundation, the plumbing, the wiring, the support beams of our digital and physical worlds. So the real question to leave you with is this. If this is the essential work AI is doing today, what fundamental new capabilities is this silent background AI making possible for all of us tomorrow?